before we can get to the semicircle, we got to start really at the circle, because there were lots of questions related to the circle. Apparently, people cling on to the old days. They were taught what a circle is in high school or college or wherever, maybe elementary school, I don't know. And they just parrot that. They just repeat it. They don't even know what they're saying. And so no one ever analyzed to see if some of these geometries, these figures that we have in geometry, or make any sense. They just accepted it, and now I'm coming in here and saying those definitions are not wrong. They're irrational. And they say, oh no, how can you say that, Bill? Everybody believes in these definitions. Well, I don't care if 100% of the planet believes in them. It doesn't make it right. I mean, the whole planet can believe in the flat earth or in God for all we care. Does that make God and the flat earth right? Or should we try to challenge that theory and say, well, you know, I don't think that's true. I have a different way of looking at things. And if there's something obviously wrong, patently wrong, then you got to modify whatever you learned in high school, in college, or wherever. And that's the case with the circle, not to mention the semicircle. Okay, so here goes. Here's one, and I'll just go with the questions because essentially it's going to be question driven. They asked me so many questions this week, made so many comments that we might as well just work with the comments, because that's essentially what it's all about. Okay, and here it is. Here you have this one. He says, circle, as Bill defines, is not an object. Well, I define an object as that which has shape, and that circle there, I think, has shape. So I don't know. He's got to define what he means by object so that we know what he's talking about. But yeah, I defined it as that which has shape, and there it is. It has shape, so it meets the condition that I have in the definition, the specification that I put in there for the word object. So I'm not sure what the problem is. But the second one is funnier. He says the 2D object is a concept. So he does recognize that that is an object. It's a two-dimensional object. There's three-dimensional objects and two-dimensional objects. This is a two-dimensional what? Object, right? That's what he said, his own words. But he says it's a concept. So we have two-dimensional concepts there. Here's, does energy have height and width? Does the idea have height and width? Okay. So I don't know how you can have a two-dimensional concept. Do concepts have dimensions? What's the dimension? What are the two dimensions or the three dimensions of mass, for example? How about that? Or intelligence? How many dimensions does intelligence have? Apparently for this guy, none, you know. Okay, another comment or question related to the circle. Okay, and it's three gentlemen here put their notions of what a circle is to them, how they learned it in high school, in college. The first one says the difference between a circle and a disc. Because I showed this as a disc, okay, and I'm saying that this is a circle. That's a circle. And they say, no, that's a disc, Bill. Okay, so what's a circle? And so these people say, well, the first one says, one is a continuous line with nothing inside. The other is a filled circle. Okay, and both are 2D shapes. Okay, and the second fellow says, a circle is the set of points on a plane equidistant from another point. Okay, that gold thing you're waving around is a disc. Okay, another fellow says that. Okay, and then the third one says a circle is a two-dimensional shape whose center point is equidistant from any and every point on its perimeter. Okay, so we have a little difference there between, I don't know if you noticed, the first one says it's a continuous line that goes around. The other two say, no, it's a bunch of points. So we already have a difference between these gentlemen. They probably don't have the intelligence to realize that they have a contradiction there. Okay, so I got to point that out to them. The two at the bottom say it's a bunch of points. The guy in the top says it's a continuous line that goes around. Okay, well, the guy in the top is wrong. Not irrational, he's just wrong. I mean, he never learned, apparently never took a course in geometry, because first of all lines in geometry are made of points. From Euclid even to today, all lines are made of points. So he should have known that there is no such thing as a continuous line. Okay, not in geometry. Okay, and the other reason is that the line is really a bunch of locations. It's not even points. The famous word point means location or number. So we have a bunch of locations, and a bunch of locations is motion. So they have locations. They have motion. That's what they're referring to when they say points. And so no, it's not a continuous line. That's the first one. And here we have proof of that, evidence. Okay, these guys like proof and evidence. Here we bring proof and evidence. if I can get this thing up there. Oh, where is it? There it is. Let me put it over here maybe. Okay, here's Euclid's circle. Okay, well, what was Euclid's circle we talked about the other day? Well, it's a bunch of spokes. That's what it is. A circle is a plane figure, okay, contained by one line such that all the straight lines falling upon it from one point among those lying within the figure equal one another. Well, each line, according to Euclid, ends in a point. In fact, the definition of line that he gives is that a line has one point at each end. So the line that Euclid concocted is made of points, and so those lines, you have to think of them as made of points, and they end in a point. That means that the circle, or the circumference, as he called it, is made of tiny dots. In other words, what are those dots? Those dots are locations, okay? And they're discrete. They're not continuous. So the line that's going around is not really a solid line, not a continuous line. But if you have problems with that, well, you still have good old Stephen Hawking and all the people today. Comes from Wolfram Math World. Says a circle is what? The set of points. These people should learn how to read. It's not a continuous line. It's a set of discrete points. In a plane, what's a plane? Well, hopefully we'll find out in a second what a plane is, okay, to make sure that we understand whether they're talking about just the points or something within the points, okay? Plane that are equidistant from a given point 0 or O, okay? Okay, so it's a set of points, so it's not a continuous line. That's the first thing we got to clarify here. And again, it shows that, these fellows sometimes don't even study geometry and they just wing it. They say, well, it's a continuous line. No, it's not. Not according to mathematical physics. Now, I don't know where this gentleman studied, maybe in a church, I don't know. Obviously, he doesn't know something as straightforward as that there are no lines that are continuous. They're all made of points. And second, they're telling you that it's a bunch of points that, are somehow are equidistant from a center. So we're done. There is no such thing as a continuous line, okay? And just in case, we have a clarification from Clark University, the people who have put Euclid's Elements, his book, online, and they not only quote him and put the translation, but they also analyze what Euclid attempted to say. Okay, and this is what Euclid said, okay, regarding, or the clarification that Clark University does with this, says, note that a circle for Euclid, right, is a two-dimensional figure. Two-dimensional figure, okay? So really we're talking about a sheet, continuous sheet. That's what a plane is, okay? But in modern mathematics, usually the word circle refers to what Euclid calls what? The circumference of a circle. So Euclid would not agree with the circle that the mathematicians that came after him concocted, which is this notion that a circle is just a bunch of dots at a certain distance from a center. That's not what Euclid thought. He thought he was thinking of a continuous line, but then, they said, well, but the line is made of points. So Euclid was contradicting himself. That's the bottom line. But anyways, the notion that Euclid had is that the circle, okay, the circle is the whole thing, the plane that goes from anything inside his continuous line. And that's not what these people are saying. These people are saying that the circle is really what? The circumference. They're saying that circumference and circle are synonyms. That's what they're saying, okay? So let's get it right. Let's find out what Wolfram says here. Wolfram says that they clarify what a plane is, okay? It says a plane is a two-dimensional, doubly ruled what? Surface, spanned by two linearly independent vectors. That means it's a surface which is spanned. Something is stretching across that surface. That's what a plane is. And they say that circle is a plane. So these people are saying here, Wolfram is saying that a circle is not the little dotted thing, the little wheel, just outside of the circle, the circumference. Now they're saying it's the plane, it's what's within these dots. That region is what the circle is, because a plane is a two-dimensional surface. And so we have to keep looking at these definitions. What is a two-dimensional submanifold? Because that's the word they're going to use. It's it says two-dimensional submanifold of three-dimensional Euclidean space. Okay, what's a manifold? A topological space that is locally Euclidean, meaning that if you go sufficiently close to the thing, it's almost flat. What is flat? A surface. Okay, and again, a topological space is a set of X together with a collection of open subsets. Blah 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 blah. What are they talking about? Numbers. In fact, you can look it up. Each one of these definitions, you'll find that they're not talking about physics. They're talking about math. And math and physics will never meet. Math is math, physics is physics, the twain shall never meet. And this is the problem. The problem is that these people try to turn physics or mathematize physics. That's what they try to do since the days of Euclid. But the important thing is that what is a plane? Okay? A plane is a surface. It's a continuous surface. That's the notion. And they say that a circle belongs to planes, therefore it cannot be just a dotted perimeter. Okay? I want to make sure that those points are clear, okay? Okay, but when all else fails, this is what you got to answer. If this is a circumference, bunch of dots going around, right? And that is a disk, according to some of these people, then what in the world is a circle? I mean, if either the circle is a synonym of circumference or the circle is a synonym of disk, what other option is there? Which one do you want? Sometimes they say it's a plane, meaning they're referring to the disk. And other times they say, no, it's just the little dots on the outside on the perimeter, in which case they're talking about the circumference. What do we need the word circle for if we have the word circumference for one and we have the word disk for the other? Okay, so this is where we're at. It is an irrational definition what they have for the word circle. It's an irrational definition because they can't make up their minds whether the circle is just the dotted perimeter or whether it is the disk itself. And they do have to clarify that. I mean, if we're going to use these definitions consistently, if we're going to apply them to geometry, then they should tell us, whoever's going to give the presentation, right? The geometer or whatever, he's got to tell us which he calls the circle. Is it the circumference or is it the disk? And as of today, we have no answer to that question. They want both. As always, they have all these dualities in mathematics. Okay, so let's go on with the there's also, to confuse things even further, it's not only those dots that are out there just static there, it's also that a circle is something that's twirling around. It's the famous figure of mathematics is a dot that's moving around in circles. Okay, so if you roll an apple at the end of a string, they call that a circle. Okay, it says equivalently, this is out of the Wikipedia, says, it is the curve traced out by a point that moves. So they have what is known as a dynamic figure. That's the other version of the circle of mathematics. So they have both. They have one where all these dots are just out there and the other one where it's an apple going around in circles. Okay, and so here we see other people trying to define or give us their notion of what a circle is. One fellow says, a set radius swiped around the reference point restricted to a plane, a circle can be drawn. Well, again, it's similar as with the one on the left, because what the fellow says is, this is how you draw a circle. So who cares? I want to know what a circle is before you draw it. What do you mean by circle? I mean, if you're going to define it. Otherwise, finish the circle and call me when you're finished drawing it. But this person's just telling you, how to draw a circle. Another fellow just gives you an equation. He said, this is a circle. And he gives you some kind of equation. There's another fellow who also gives you an equation. But see, the interesting thing about that other equation, the one that's got the powers of 2, right, squared, it means they're talking about a surface. They're talking about, if that's a circle, then they're talking about, again, a plane. They're talking about, they're saying the circle is the whole thing that's within the perimeter of those dots. And then a third guy says circumference, and I guess he copied this from the wiki also because I saw the same thing there. It says circumference, in geometry, a plane curve, plane, you mean like plane, you like surface, you mean like a sheet, continuous sheet? Is that what a plane is? Plane curve, the locus of points equidistant from a fixed point, C, called the center of the circumference. Again, so is the circumference the same thing as the circle? And then he continues, as the circle is the flat, what? Surface enclosed by a circumference. And again, we have a problem because we don't know whether the circle is the circumference or circle is the disk. And until this fellow can tell us that, he can't give his presentation. We need to know what he means by the word circle. And right now, everybody's confusing circle with circumference in one instance and circle with disk on the other. Okay? So once again, I repeat, this is a circle. We point to it and say circle. Okay, now this one is a 3D. I use it for representations only. You can only put a circle on paper. And it's got to be final. It's got to be there already. I can't say, let me draw it for you. No, I don't care. Call me when you're finished drawing it. And then you got to describe what you drew. And if you're going to say that it's just a circumference, and that the circumference is a solid line when all lines in mathematical physics are made of points, discrete points, which are not points, which are locations, which are really numbers, ordered pairs, that's what they are. So what the hell are we talking about after a while? We have no idea, okay? Because the fellow has to tell us what he means by circle. And one of the problems there, people say, well, Bill, what use do we have for this, for this disk, your famous disk? We don't care. We don't care what use you have for it. Here we're trying to find out what a circle is. This is what a circle is, okay? And if people don't like this, then they have to tell us what a circle is. And if they're going to define it, it's not a figure. Because in science, we do not define objects, figures, things. In science, we point to them, okay? So you point to a circle, okay? If you're going to define it, then you're talking about a concept, and concepts are not figures. That means it doesn't belong in geometry to begin with. We don't have concepts that are figures. No, it's either a figure or it's a concept. And if you define it, it's a concept. It's that simple. Okay, so what is a semicircle? Let's find out. Well, here it is. Okay, it's half a circle. This is Euclid's version. Okay, it's in his definition 18. Okay, in book number 1 of Elements. So a semicircle is the figure contained by the diameter and the circumference cut off by it. Okay, so that's Euclid's version. Again, so he made his circle with lines. There's always a line between any two lines, so his circle is never finished. It's known as the unfinished circle. Okay, and he says it's a continuous line that covers that circumference. He's wrong there too, because all lines are made of points, discrete points. That means between any 2 points you can fit another one, according to Euclid and according to math today as well. So the whole definition is screwed up. It's no good whatsoever. It's irrational. Okay. And the center of the semicircle is the same as that of the circle. Great. Okay, that's Euclid's version. This is the one from mathematical physics today. This is today's version. Maybe I should put it over here next to Euclid's famous semicircle. Half a circle. That's what Wolfram calls it. That's what a semicircle is. The area, and it continues, it says, the area of a semicircle of radius r is given by blah, 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 blah. Area? What do you mean area of a semicircle? I thought a semicircle was just those dotted lines. Why are you talking about area of a semicircle? So we have a problem, because now suddenly they define it as a bunch of points, but then when they talk about area, they talk about the area of the circle, and they're referring to the circle itself, what's on the inside of the dots, within the perimeter. And you see this when you look up the word cylinder, also from Wolfram. A solid of circular cross-section in which the centers of what? Of the circles all lie on a single line. What is a circle according to the cylinder version? Well, it's a cross-section, a slice of a cylinder. And that means they're talking about not just the outer rim, they're talking about the area within the rim as well. They're talking about that surface. That's what a plane is. Okay, so these people have to make up their mind. They can't keep going back and forth and saying, this is what a circle is, and then they don't use that notion of a circle because they're going to be using this notion, the slice, the cross-section. Okay? So this is where we have a problem with all these people, because they're not using they define one thing, then they don't use it. They say, well, we're going to take a slice of a cylinder and we're going to call that a circle. That's not how you define it. You define it as a bunch of points. What's this nonsense about now saying that it's a slice? It's a continuous surface from perimeter to perimeter, from one side of the perimeter to the other side of the perimeter. Which is it? And of course, they can't answer that question because they say it's both or none. Depending on whether they want to overrule you, they say, well, it's none, so don't attack us. Okay, so here's a little summary of the circle from my point of view. Okay, mathematical physics is the vain attempt to merge mathematics and physics. This started with, at least with the Greeks, not earlier. Why? Because they had a surface, or they had some object out there, some figure, could have been a cube, also a solid, and they immediately try to measure and look at the relationships between measurements. That's how this grew. That's how geometry was born. So here they had a figure which belonged to physics, and what they did was they brought math, measurement, units, numbers. They looked at relations, and all that belongs to math. That doesn't belong to physics at all. And you cannot have physics and math and physics. Never the twain shall meet. Okay, and this is where the problem is. That's how we ended up with a religion of mathematical physics today, and that's why we have all this nonsense out there like black holes and dark matter and dark energy and particles at two places at once, because it's a vain attempt to merge mathematics with physics. No, math is not the language of physics. The language of physics is illustration. In the religion of math, phys, right? A line is made of infinite points. That's according to their own rules. This is not me putting words in their mouth. This is according to the horse's mouth. They themselves say that a line is made of points. That's never changed since the days of Euclid. In fact, if you look at Aristotle, he said the same thing. I covered that in the past as well. They talk about motion. For every location, they call that a dot, or they put a dot and they call it a point. And what does that point represent? A location. What are they talking about? They're talking about motion. And that's what a line is. That's why they talk about one-dimensional line. And you say, what do you mean a one-dimensional line? What kind of figure, geometric figure is that? No such monster. You cannot even imagine a one-dimensional line. Why? Because they're not talking about dimensions. They're not talking about lines, figures. They're talking about motion. Mathematics has no use for lines. Mathematics has no use for dots. Mathematics has no use for planes or solids. Is a solid hollow? A cube, when they say cube, are you thinking it's a hollow cube? Or why do we call it solid? It's solid, right? Yeah, these people want to make you think that it's just the perimeter, the outside of it, the surface or whatever. Okay, in physics, no object is infinite. Okay, maybe in the religion of math, object is infinite, but not in science. And all objects are finite by definition. What is an object? That which has shape. Hopefully all shapes end somewhere. Okay, so they're all finite. In physics, the amount of matter in existence is finite. Okay, God does not create matter every day. We cannot turn space into atoms and atoms into space. No way in either direction. And so the amount of matter in existence out there, wherever you go in the universe, the amount of matter is constant. Okay. In the religion of mathematical physics, a point is a misleading term that means neither. It means either location or number. That's what the word point means. So they use the word point because they want to incorporate both notions. Location, which is a concept of physics. We talk about the location of objects, okay? And has nothing to do, the qualitative notion of location has nothing at all to do with math. Math has no use for the qualitative notion of location. That's why they don't use the word location. They always talk about position. And what is position? Well, it's an ordered pair, an ordered triplet, or whatever. It's a bunch of numbers. That's what a position is to a mathematician. It's got nothing to do with you having distance with respect to me. That's why they never were able to define what location is. They don't have a use for such a word. And they don't have a use for the word motion either. They use displacement or, something along those lines. They're not going to use the word motion, meaning qualitative motion, because they have no use for that. Just like they have no use for the qualitative time. They only have use for quantitative time. They have to use seconds and minutes and years and whatever. They have no use for saying before and after. Math has no use with those type of notions, those concepts. Okay? Neither location nor number is a figure. So if a point is location, if a point is number, well, then they're not talking about geometry, because geometry first and foremost is what? The study or the analysis of shapes. So you have to have a shape. And if they're going to start with a point, which is the building block of geometry, and they say, well, what is a point? Well, it's zero dimensional. That which has no part, Euclid said, meaning there's nothing there. Because he was referring to location, not to a geometric figure. Okay? So yeah, we have a problem already. Starting point, there are no such things as zero-dimensional points or one-dimensional lines in physics, maybe in the religion of math, math phys. And then the line of math phys is an itinerary, okay? It's made of points. The point is location, so we're talking about itineraries. And of course, when you raise these issues with these folks, They don't like to hear that because this is what they studied in school, in high school, and college. And so they say, Bill, are you telling us that for 2,500 or 3,000 years we've been wrong? No, you've been irrational. And if it's irrational, you have to challenge it, not accept it on the basis of authority. These people are accepting all this stuff on the basis of authority and tradition. They say, well, this is how I learned in school, and this is what everybody out there believes in, and that's what I'm going to use. Well, yeah, go ahead and use it. I'm just telling you it's irrational because the definitions are irrational. They contradict each other. We don't know what a circle is. And when I challenge these people, the only argument they have is authority and tradition. That's it. They have no other argument. They cannot challenge what I'm saying because I'm saying something that is straightforward. I'm showing them, according to the definitions of mathematical physics, according to the definitions of geometry itself, they have contradictions here. And if they have contradiction, they have irrationality. You can't use those notions consistently, and they can't, and they don't. They don't use them consistently. They just switch over whichever one they need. Whenever they need for the circle at least, whenever they need the perimeter, they use the perimeter, and they call it circumference, circle, whatever they could call it, whatever. They could call it X. And whenever they need the disk, they say circle, disk, or whatever they need to call it. Again, they can call it Y for all we care. We have a contradiction, and so we don't have a circle. And if a semicircle is half of a circle and the circle is already irrational, well, we have an irrational semicircle as well. Okay, just maybe a corollary here, if I get it in there. It's all the way at the bottom. Let's get a little corollary here, put it on this side. Okay, what's the corollary? The corollary is that the circle of math is not a continuous curved line, okay? Because all lines are made of points, dots, meaning locations, meaning numbers, ordered pairs. So if you're talking about 2D, right? And so the circle of mathematics is not a continuous line. That's the first one I want to challenge, okay? So anyone who thinks that is fighting the establishment, not me, okay? It's made of discrete points. That's the first thing you have to understand. If you haven't learned that, well, you haven't taken your first course in geometry, okay, in school. Mathematics, there are gazillions of points between any 2 points. Okay, that's the worldly wisdom in geometry, in mathematical physics. So first learn the basics, okay? The circle of mathematics is not a plane, okay, because they say it's just a bunch of dots that form a perimeter. And then, they always talk about surface and they always talk about area. So you say, well, what do you mean it's not a plane? Is it a plane or is it not a plane? If it is a plane, then the whole disk is a circle. This is a circle, okay? And if you're just going to talk about a perimeter, then you're not talking about a plane. That's not a plane. Okay, a bunch of dots is not a plane. Okay, what is it? It's a ring made of discrete points which are not in touch with each other. Okay, so there's holes everywhere between any 2 dots in the perimeter. The water is leaking out through all of them. And you can plug it with more points. Just put as many points as you want. I'll put another one in between any of your 2 points. So you can't plug the perimeter of your so-called circle. Okay? It's not a hula hoop made of a single piece. No, it's got all these little dots, okay, that form the circle. And then concepts we define. So if they're going to define a circle, it's a concept. And no, then it doesn't belong to geometry. It's not a figure. Figures, objects, we point to.